So solving the first one on this page, number 27. What is the volume in this first one? Do you see a volume anywhere?
0.
A spray can is used until it is empty except for the propellant gas. You ignore that part. Which has a pressure of this and a temperature of this. If the can is thrown into a fire with this temperature, what will the new pressure be? And what I'm getting at is it doesn't mention volume. You see that? Solving these problems this is just the first step. You decide what's being mentioned, what's being enumerated. How many moles is in there? Does it say how many moles is in it? So that's not even mentioned. Only pressure and temperature are mentioned. Once you narrow down to that, R is never changing in these types of problems because it's a constant. But what you want to do is use algebra to get what's changing on the left side of the equal sign and put everything that's not changing on the right side. Volume's not changing, I want it on the right side. And number of moles is not changing, it's already on the right side. Temperature is changing, I want it on this side, so I'm going to divide both sides by temperature. So that was just algebra. Getting what's changing on the left side and everything that's not changing, that is staying constant, on the right side. If it's not mentioned in one of these types of problems, then it's not changing. I mean, you can't answer it if they don't tell you, right? If you got an old volume and a new volume, if they don't tell you, so they just don't mention it sometimes. So pressure and temperature are mentioned here. They're the only things changing. You infer that because the other things aren't mentioned. They might mention them, but if the container stays closed, then the number of moles stays the same. And if the container doesn't change shape or whatever, the volume stays the same. So if you do that, then you just do this. You take what's on the left side and you go, you put ones on the left and twos on the right, and that's all you need to solve the problem. You have 4 variables to work with, and here they are. Temperature 1 was 296.15. Temperature 2 equals pressure 1 they gave us 1344 torr. And you're just solving for P2. Following this process, deciding which of those 4 variables is changing and which are not, and then getting the things on the left of this equation that are changing, everything on the right that are not. And then you just duplicate the left side like this with 1s and 2s. So to solve this, it's just algebra now. I'm solving for P2, so I'm going to multiply both sides by T2, so I've got T2, P1, and that's what I'm going to use to solve it. So I've just multiplied both sides by T2 to get it to look like this, and now I can just plug things in. T2 is 748.15. P1 is 1344. I should be putting units in here, but they're going to cancel down to torr anyway. T1. Oh, am I solving one that has the answer to it? Well, it's all right. I want to leave those for you to be able to practice. Hopefully I come up with what they get here. Four significant figures. My calculator gives me 339 5.28482. There's my four significant figures. I got these out of a book.
Yeah, I was
They
curious.
boiled it down to two significant figures. That's not right. Or I guess that's three. But it should be four.
So would be adding,
Um,
even though at the Kelvin,
Yeah, they gave us these in degree C.
but did we keep sig figs when we added those?
Um,
I'm trying to remember the additions. and
oh, you're
subtractions.
right. So I should have just kept that. Yeah, you're right. So it would be three. You're right. You're right. So after those additions, I would just have that. You're right. So it is three. So this is. If I don't specify standard scientific notation, then it would have been okay to leave it as four. No, actually, this one you couldn't do it because that's not significant and that is, so you have to do scientific notation there. All right, so let me solve these that don't have answers. Let me just kind of model how this works. Always start with PV equals nRT. So the next one there, I guess, is 28. I'll give you a link, but these are from that OpenStax chapter. I'll show you where they are on the web. All right, this one, 28. Saying what is the temperature when you have this many liters and this pressure, 744 torr, and what is the temperature? They repeat torr twice. Well, they're just telling you everything. They give you temperature, they give you torr, they give you liters. Oh, this one is changing, okay. So let me just do it the way I did it before. Which of these four things is not mentioned here? Problem 28, which one of these is not mentioned? Temperature, volume, number of moles, or pressure.
Temperature?
That's not mentioned, you consume it's not changing. Right? It's not mentioned, right? All right, so you got PV and T. You need PV and T on this side and N and R on the right. So it's and then you just write down PV over T, PV over T. You put ones here and twos here. And now you plug and shut up. No, I take it back. N is not changing, so I've got it crossed through. Pressure, that's not changing either. They said 11.2 liters, 744 torr, and then later it's 13.3 liters at 55 degrees and 744 again. So actually we can ignore this because pressure's not changing. So if they don't mention something, it's not changing. If they do mention it and what they say about it is it's not changing, you can ignore it just as well. Okay, there. PV equals nRT. Volume over here, I need NR over P. That's actually all you need. You don't need that 744 torque to solve this. So thinking like this, deciding what's changing and what's not is the first step. And then, what am I doing? Volume. I'm looking for, what is the temperature? Okay. That's what it's asking for. What is that temperature when the volume is 11.2 liters? If later its volume is 13.3 and 55 degrees C, so if I add these, look at 8. So that's the actual temperature. All right, so do you see this, that's the temperature they're looking for? This is the original volume. It gets to a new temperature and a new volume. So that's where our question mark goes. T1 is the question mark. So now we just solve T1. I want to rearrange this so it's multiply both sides by T1. Now divide both sides by V2. I just manipulated this so I had T1 by itself. In case I lost you there. What am I doing? Multiply both sides by T1. That gives you V1, T1 over T2. Now I've got T1 by itself on the top. Now I multiply both sides by T2. This is just algebra. Now divide both sides by V2. So there's the algebra. I had to make sure I didn't do it wrong in my head. And the rest is just plug and chug. So V1, 11.2. I'm skipping the units here. T2 is 328. And V2 is 13.3. Came up with 276. Was this torr? No, that's temperature. Okay. I should put my units in so I don't get confused. All right.
And we could put Kelvin for that. We don't have to take it back to Celsius, right?
Depends on what you're asked.
It doesn't specify.
Yeah, so it just says what's the temperature. If it was me, I'd just leave it because it's not asking for the extra step. Let's do 30. All right. 30. I might skip 30, just because they threw a twist in there on you. Let's look at 32. Pascals is another make sure I've got the right value. .314 kilopascals per mole Kelvin. So I should have had this one on the sheet. 8.314. Kilopascals. Mole Kelvin. All right. Assume I'll give you the R values, but if I'm going to solve this one, I'm going to have to use this. All right. PV equals nRT. So there's not a initial and final here. Volume is 66.8 liters. 273.15 plus 25, so 298. 298 K for Kelvin. All right. Nitrogen gas is N2, so we need the grams per mole here. I'm trying to find the moles. This is what I'm looking for now. So that's grams per mole, and we have, keep losing it, 77.8 grams. This is all N2. So we will get the moles first. .8. 77.8 divided by 28.2. Three significant figures, so 2.78. So now this is 2.78. The R value, I'm going to use this R value, so I'll land in kilopascals. And yeah. So N is 2.78. R temperature is 298. Volume is 66.8. nRT. 2.78 times 8.314. 298 divided by 66.8. I end up with 103. kilopascal. But assume I'll give you any constants that you need, the R constants. 33. Is solved, 34. Okay, so we need grams per mole again. We're given milliliters, which will convert to liters. So it's in the same units as the R constant. We'll calculate what 0.292 grams of I2 is. And we're in atmospheres for pressure. So mole will be in liters, atmosphere, so we're going to use 0.08206 Kelvin for our value. What's the molecular weight of iodine?
126.9.
And times 2. $253.8.
Yes.
Okay. It's going to be tiny. 292 divided by 253.8. That's how many moles. And we've got 73.3 milliliters. I'm just going to convert that to liters, moles, what's about 0.462 atmospheres, which is a pressure, and then it's asking for temperature. What is the temperature? Yep. Crap. What were the liters?
0.0733. Point 00115.
All right. PV equals nRT. I'm solving for T, so I can go PV over NR equals T. So divide both sides by N and R. Volume. And my R value is this. And because I'm being sloppy with units, I better go ahead and put K there. All right. You guys see what I'm doing? Did I lose anybody? Are you just tired? You guys good?
Yes.
462 times 0.0733 divided by 0.00158206. I'm getting three significant figures, so 359K.
So volume has to be in liters.
If I gave you an R value that had something besides liters, like milliliters or something ridiculous like gallons, you can trust it, I'll give it to you. But yeah, I think we always do liters for these in science. Metric system, it's always liters or milliliters or nanoliters or whatever. But for some reason, there's the several different ways of expressing pressure have just lasted through history. 36, 37. Seems like I should have had an answer to 37. Which one did I cross off?
30.
30. That was not hard, but. I'll solve one more. 37. So there's that. 36 and 37. Well, I found the answers earlier. That's weird.
It's usually at the end of the textbook, right?
Yeah, that's
It's so weird.
upstairs when I opened this. It was there. All right, I'll solve 36, and I'll solve 37 and give you the answer to it. Okay, we have a balloon that's 1.41 times 10 to the 4 liters. Torr. Pressure, volume, volume, 10 to the 4 liters, 273 plus 21, 294. Volume, temperature, pressure, 745 torr. You could ignore the 20 kilometers. So what is the new volume of the balloon at 20 kilometers? Or we're at negative 48 C, and the pressure is 63 torr. So those are our initial values. Our final values. Our new pressure. And the new volume is what they're asking for. And the new temperature is very cold. 273 minus 48. I know I can't do that in my head real quick. 273 minus 48, 255K. And what's the deal with malls here? It's not mentioned, so you assume it doesn't change. The balloon is sealed, so nothing comes out of it. So that's what changes, P, V, and T, so. Oh, we don't need the R value for these types of problems because it stays constant. So you just go and you just plug and chug. You've got 5 out of 6 of those and solve for the 6th. We're solving for V2, so I'm going to go P1, V1, T2. Multiply both sides by T2 and divide by P1. So the rest is just solving. 745 P1. V1 is, let's do 1410 liters. 1, 2, 3, 4. 1, 2, 3, 4, yeah. To get the power of 10 out of our way. T2 is 255. T1 is 294. P1 is 745. That's it, you just solve. 745 times 14100 times 255 divided by 294 divided by 745. So we're solving for volume. So I'm getting for a solution but we're keeping 3 significant figures, which is that. 1, 2, 3, 4. 3 significant figures. Yeah. 1.22 times 10 to the 4 liters. How did it get smaller? 2, 3, 4.
Is it because the temperature dropped?
Oh, at high altitude, and then it goes to a lower altitude. Yeah, that's right. I'll solve 37 and give you the mixture of that. But practice these, so there'll be some of these on test 4. We'll stop there for now, and then y'all come back at 2, and I'll lecture some more. If you didn't get any copies of these, they're all here. Any of you got questions? All right. So that's video 2. We'll have more video today.